Right, so we're looking at a slope field. You've seen some of them, but what it is the graphing representation, so they have all these slopes along here of some kind of differential equation, okay? It's a graph of short line segments. Slope is determined by the derivative at each of those segments. So let me just show you what I'm talking about before we actually do one. So, why is this not moving? Okay. All right. Your slope fields that are already done there's one like that, okay? These little segments here represent the slope. Now, this slope is steeper than maybe this slope, okay? And that's all you can really get from, you can't say, oh, that's -4 or that's 4. You're not going to be able to get that precise. It's a picture, which is the graph of all the slopes, okay? And the slopes come from the Diffie cube. Remember, this means slope, okay? All right, so let's go back and just back up a little bit to where they come from. All right, so we got a family of functions here. It looks like maybe y equals x squared plus 1/2, maybe y equals x squared plus 3, y equals x squared plus 2, y equals, and I didn't put them all on here, y equals x squared minus 4, so on and so forth. Okay, those are some of the graphs that are already here. Now, the only thing that they differ by is this constant. That's that c, when we maybe will have y equals x, would be the, no, you're getting ahead of me. It'd be, anyway, I'm not going to worry about it right now. Okay, so the slope field looks like this. You're going to take a tiny little segment, and I'm going to get my line out just so I can have some straight lines. And I'm going to draw slopes at every kind of hip stitch here. They should be back behind as close as you can. Okay? Once I'm done, what I'd like to do is, if I can, take away the blue piece. Okay? So that's like a part of a slope field. Same with this one. I take my lines and I draw some more slope fields. Basic, oh gosh, it's moving on me. I can't, stop it. I can't lock it because then I can't move it. But I'm going to do them all, and then you're going to look at a, come on. Keeps wanting to move on me. My line, let's see. Is that what happens? Okay, so I'm going to quit doing this because they're annoying me. All right, so once I fill this all in, now I only have the family of functions that are like in this little area. I will have the whole slope field. Okay? Now, that is not how you make a slope field. That is where the slope field comes from if you were going to do that. Here's the thing. You cannot possibly put all the solutions of every graph along here with every single k that you can think of. But that's what you have a picture of. Every k in the world, well, from -6 to 6, is on this graph eventually of your slope field. Okay. So that's how it's prepared, but that's not how we're going to do it. All right, let's look at how we're going to do it. And like I said, it's a tedious little process. Okay? You get the lattice points, which is the dots. Okay? Typically, your Diffie cube will look like this, where dy dx is some kind of function. Okay? F might include X, it might include Y, it might include them both. It may include no, it might be have a number. We'll do all that. Okay? You take the X and the Y coordinates, you plug them in here, and that will give you the slope at that particular point. Okay? You graph a little straight line that maybe have a slope of 1. Okay? And then you go on to the next order pair, yada, yada, yada. Okay. Now, the ones I'm going to show you are going to be computer generated, so they're really tight. The ones that you're going to prepare, we could go, we're not going to get that tight. So they're not going to be as nice looking, but we'll start with an easy one. dy dx equals 1. All right, now what does that mean? That means all the slopes on the whole dot paper are 1. Okay, so you're going to decide, what does 1 look like? Well, remember, 1 is up 1 over 1. This is your line, what 1 looks like. Okay, so what you want to do is draw a line at every point that looks the same. All of them. We'll just go. Now, I did one goofy one so you can see when you look at it, if they aren't the same, they'll look different. I'm going to quit here soon. Okay? Through the dot. Yeah, the dot should be like the middle of the little line segment that you're drawing. Okay? And that line should be, you know, we went kind of off to the side, it should be all, they should be all like that. That's 1 up, 1 over, and that's a line of 1. Now, when you look at that, they should all look the same, except for one I did wrong. You see it? It jumps out at you. So let me get it fixed here. This one should be a 1 as well. Okay? That's the easiest kind of slope field that we can draw where they're all the slopes are the same. All slopes at every xy are 1. Okay? That's the easiest you can do. No x's involved, no y's, just a 1. Okay? So let's try one that gets a little bit harder. It has an x in it. Remember, it can have an x, it can have a number, it can have an x, it can have an x and a y. The more involved function is, the more we're going to have to do some work. Okay, now I'm going to make a little chart for my x's and my y's. And at any point where you see some kind of a pattern instead of plugging in individual x's and y's, you know, let me know. Okay, so let's take 0, 0. If I put in a 0, 0, my y really isn't going to matter, right? So I'm going to put in all the x equals 0s. What's 3 times x equals 0 going to be for my slope? 0. Now, the 0 slope is going to be your favorite, because it's the easiest one. What's the 0 slope look like? Horizontal line. That's right. So where is x equals 0 on this dot paper? 0, 0 is what spot?
On the y.
Y-axis is x equals 0. That's right. So all the way along here, I'm going to make x equals 0. Those are the easy ones to draw, and they're the easy ones to pick out, the horizontal ones. Okay, so since y is not involved, let's do x equals 1. Okay, we're plugging into here, so 3 times 1 squared equals what? 3. Okay, now 3 is pretty big compared to, you know, up 1, 2, 3 over 1. That would be a 3 slope. Okay? You don't have to get exact. You just make it kind of steep. So 3.
Why are you doing those there?
Because that's where x equals 1, right there. Okay? Now, how good did I do? This is an actual 3. Not too bad. That should have the same slope. okay? But when you look at it, here's what needs to, regardless of if you did a very good job, they should all look the same. There shouldn't be any that are flatter, like, let's say, we're going to do, okay, that one's off. So you don't want to be eyeballing this and looking at, wait, why is that one different? It shouldn't be, okay? All right. What other ordered pairs? Usually I like to plug in between -2 and 2.
Awesome.
-2 and 2 for your slope field, that's fair. That's a lot of points.
You can do the same thing for reciprocal.
All right. Okay, sounds good. So I'm going to draw a 3 at x equals -1. So these on this side should look the same. Okay. I'm assuming I'm in ones because it doesn't tell me any differently. That's a good assumption. What happened to this when I erased it? Okay. So again, when you eyeball this, should all be the same. All right. If we go out to x equals 2, we get pretty steep pretty quickly, right? 3 times 2 squared. What's that? Well, yikes. Okay. If you think about it, I'm going to go up 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's going to be almost vertical. I just got to make it steeper than this. So steep. I don't want to make it vertical, and same with x equals -2. Just make sure it tilts to the positive. Okay. Once they get past my grid, it's just really hard. But these right here, x equals 2 and x equals -2, all you have to remember is that they need to be look steeper than these guys.
Mm-hmm.
We're done.
We're just doing from 2 to -2.
Yeah. I mean, I did. It can get really tedious and like, and sometimes they're so far apart you can't really see the pattern. If you look at the ones that I computer generated, look, this is 1, this is 2, and this is 3. So, you know, I've got them divided into almost fifths. So it looks like something when you're done. All right. Does anybody have any questions about drawing a slope field? Okay, so we're progressively getting harder. This is the easiest for 1. Then we got an x involved. Now we got an x and a y. Okay, and we got a negative. So we're going to plug some word pairs in. This is when you're going to be like, this is annoying. Okay, so let's talk about x equals 0. I really like the zeros. If x equals 0, what's going to happen to the slope dy dx? It's not going to exist. So what does that mean on the slope field? No, you leave it blank. It is. But the problem is she's got the right attitude, but the problem is these almost look vertical. So if you're going to really draw a vertical line, you're going to have a hard time telling the difference between a positive 12 and an undefined. So the rule is, and sometimes the computer doesn't follow the rules, so be careful. The rule is, if it does not exist, the slope does not exist, leave blank. Okay? So keep that in mind. Let's see. Leave blank. Okay. All right. Now let's go to, how about y equals 0? So what should, before we do y equals 0, what should be blank? X equals 0, what is that?
The y-axis.
The y-axis, so leave that alone, okay? This should be blank. And I'm just doing that for my purposes. Please don't write blank.
Are we just assuming that, like y would be 1 or whatever else? Well, if there's 2 variables, like with this one, with y equals 0.
First y equals 0. All y equals 0. What's going to happen to the slope? 0. Okay. Y over anything is always going to be 0. Even a negative 0 over anything is going to be 0. Okay, so where's y equals 0? X-axis. So I'm going to draw, if you can't see it, I'm gonna make a mistake. You ever see my mistake? That's right, Claire, good job. This has gotta be blank. Because that's a long x equals 0, that does not exist. Okay? If you want to raise them a little bit just so you can see them, because sometimes they kind of meld right into the axes, go ahead, it's fine. Okay? That's about as generic as I can go. Let's talk about when 1, 1. Now we got to go to individual ordered pairs. I'm going to plug in a y, and I'm going to plug in, and what am I going to get for a slope? -1. Okay, -1 goes down and over. So it looks like this. All right, so at 1, 1, I'm going to go here. All right, where else is going to be a -1?
-1, 1.
Nope. Because I already have the negative.
-1, -1.
Yes, -1, -1 will give me a -1, -1 will give me the same slope, so that should look the same as that. Where else? What's the matter, Emma?
It's going to be +1 at -1, 1, and 1, -1. Yeah, so it's going to be +1.
-1 over -1. Right. All the what?
Would it be on all of them?
I don't think so. This y doesn't equal -1. Will it be what?
Everywhere that x equals 5.
Yes. Very good, Hannah. Everywhere x equals y. So that's along the diagonal. We're going to have a 1. 1, 1, except for y equals 0. We're going to skip over that. Okay? Again, if you're really weird about the whole sloping thing, you get out your ruler and that should be the same. You can't be too weird about it just because they'll drive you crazy. I'm not going to be weird, but I got to see a difference between -1 and +1. Okay, I got to see a difference between 1 and 2. That's what I'm going to be looking at. Okay, no, I'm not going to be weird about it. Okay, where am I going to get? How about let's do that. 1, -1. Where they're opposites. What's my slope going to be now? 1, because I'm going to do negative from the formula. -1 over 1. Okay, so 1, -1 is right here. I want to be a +1, right? So I'm going to go the other direction.
It's going to be the same on the diagonal.
Same on the other diagonal except for 0, 0. Good job. See, you all are just unpredictable. Okay? But you got to look for those patterns because otherwise you're going to be at this like for the rest of your life doing every ordered pair. Okay, so now we just have to fill in with some of these other ordered pairs. There's patterns. There is, if we want to care to look for them. Let's see. So all the diagonals, we did those already. Let's look at some other ordered pairs. What do we got left? Like, how about a 2, 1? We're going to plug in your -1/2, right? Okay, so that would be like for 2. If we want to go out that far, we probably won't. So 2, 1, how about -2, -1? Would that work too?
Well, yeah.
Okay. The -1/2. Okay, the -1/2, remember, will be more shallow than your 1 because it is, remember, up 1 over 2. This is 1/2. I'm making kind of a pass, but I like to do my little practice, and that's kind of, I eyeball that now. So at 2, -1, 2, 1, sorry, I'm going to do one that's a little bit more flatter. So that should be, see, if you compare this with this is flatter than that one. Okay, and that's what I'll be looking at. Okay, -2, -1, flat. Okay, how about how about 2, -1?
Flat the other way.
That'd be flat the other way, so 2 negative 1 would be this way, like this. Okay, and probably negative 2, 1 as well, right? Okay. So we're going to fill in. We basically, if we're going just to 2's, we have 1, 2 left. Be a mess here. 1, 2 we have left. And so that just takes care of, and 1, negative 2 we have left. Negative 1, negative 2, and negative 1, negative 2.
On this one, since we kind of see a pattern forming, can we just say that, like, they're going to get steeper as they
Well,
approach?
you don't get to say anything. You can fill them in if you know what they are, but you don't say, yeah, if you see a pattern developing, then you just put your line segments on there instead of doing it. I'm not going to look, if I say, I don't know, I'm going to look for this, but otherwise I'm going to look at the picture, which is the graph. Okay, so 1, 2, what am I plugging in? 2 over 1. 2 over, that's negative 2, right? Okay, so that's going to be steeper than these ones here. That's a 1. Okay, if you need to eyeball it, it's up 2 over 1. That's a 2, but we need to go negative 2, right? So down to, get in there. Down 2 over 1. That's what a negative 2 looks like. Okay, where's that? 1, 2. 1, 2, down. Okay, so when you look at these side by side, they should not look the same. Okay, and then where else do I have a negative 2? Any of these other order pairs?
Negative 2, negative 1.
Negative 2. No, I already did that one.
Yeah,
Negative 1, negative 2.
negative 2.
Okay. Negative 1, negative 2. Negative 1 down, negative 2 should be the same as that. The biggest deal for me is the negatives and positives. I get those mixed up all the time. So that's what you got to be careful. And then these are probably going to be positive. And we did that one. That's probably going to look like this. Sometimes not.
Why would it look like that if it's positive?
Did I not do it right?
No.
This one?
No, the other one.
Oh,
dude.
Which one? This one?
Yes.
Okay. That should go the other direction.
Yes.
I was kind of ready for it to be down. Okay. Miss Hall will tell you a story. Ask her about her slope fields. If you know Miss Hall, she said she just would like do random things, and the calculus teacher at the time said, "Are you just like drawing random lines?" She said, "Yeah." All right. Now this is the computer generated of this. It's going to look way nicer because they're closer together. Okay. So this is dy dx equals negative y over x. This is the computer generated graph that we were working on. If you want to compare,
It's, yeah.
wait, is it? You can't see the things there, but yeah, you can see, yeah, I think, well, anyway. Okay, so let's make sure we understand what the purpose of these guys are, okay? Keep moving this thing. Unlock. Okay, here's the purpose. All right, we have the whole family slopes over here. Okay, that's the whole family. We want the particular solution. Remember your Emily's over here. She had a particular one that went through 2. All right, and then over here on the first 4, 5, 6, 7, 8 on your homework, we left it with C. Okay, these are all the C's that you could think of. All right, and then some. All right, so let's find the ordered pair of 1, 1. I believe it's about right here. You've got to pay attention to the scale on these slope fields because it's not always what you think it's going to be. but it's always labeled. Okay, so 1, 1 is there. Now, if you remember when we drew our slope fields here, we had specific solution. Let's read my voice right at the moment. The slope fields were behind. So now what you got to do is you got to take and draw a solution that the lines, these little guys, or these guys, or whatever, sorry, is going to be, the lines are going to be behind. And this is like that line of best fit that you're like, that's not that good, but so I'm going to take this and kind of go here like this. And what should I do with that? Should I go up? Should I go like that? Well, that's really stupid because look how many I just like ignore, okay? And I hope I'm not stupid. All right, so what do I want to do? I'm going to go up here and just kind of here. Now, there's not any lines behind here, but we don't want to make any sharp turns. This is a curve. This is the curve that goes through 1, 1. Okay? That's all we know about it, and these are the slopes. I shouldn't even have this bump here, so I'm going to fix that. Okay? Sometimes you have to make a decision. You don't want to cross over because then if you got a slope that looks like this and your curve looks like that, that's not a slope that's underneath your curve. Remember, that's supposed to be underneath. Okay? But you'll figure it out. But that's what you're going to do, is you're going to draw the solution curves. Then what we're going to do is we're going to put what we did today, the solutions, and we're going to draw them in here, and you're going to be amazed at how close you can get by just that slope field. Okay. So, yeah. Somebody said one time it looks like somebody's facial hair. Like every which way it's going. Yeah. Okay, so here's your slope field. Computer generated, we're going from 3 to 2, 3, okay? So pay attention to the curve. We want to do one that goes through 1, 1. We want to do one that goes through 2, -12, 1/2, sorry, wow. And then we want to do another one that goes through -1, 1. So do them in 3 different colors so you can tell. 1, 1 is probably about right here.
It can't cross.
You don't want to cross. Right. Try not to cross. Sometimes you have to kind of like, I got to make a decision at that junction, and you just do the best you can.
Looks like it comes back up though, over here. It doesn't just stop.
No. Okay.
Should I do? So you should come back. Stop.
Alright, we got a red one. This one, why did it stop? There's no vertical lines that should stop. It should continue to go.
So you do cross
The border
with the X and Y axis.
Yeah, the X and Y axis, unless they have vertical, very vertical, or they're totally blank, that would be like an asymptote. Looks pretty good. I'm going to show you what if you do them with the computer, what they look like, but yeah, that looks really good. Don't stop it if there's not any stopping point. The axis does not stop anything.
How do you know if it goes?
Well,
I'm confused. Like on this one.
okay. What about it? Well, you just have to follow the slopes. Looks like it's weird. Kind of follow them there.
Laura,
Whoa,
It's my
straight line, yeah.
Okay.
All right. On my red one, I'm gonna go up here like this. Okay? And then I'm gonna go down. These you can't see them very well, but they are definitely horizontal. And then it looks like maybe I'm gonna go out this way.
I did that.
So there's really no correct answers.
There's incorrect answers, so yes.
But if it's like that shape, is it okay? Like, does it
Yes.
have to be exactly?
No, it does not have to be exact. The shape, yes.
Okay.
It should look like a parabola or a square root or whatever. It should look like it shouldn't. Now your green one, I don't know that you followed your green path very good there, but maybe you did. Your green one starts as 1. Did I erase my green? Starts to go negative 1, 1. So I'm up here. And maybe I'm just, okay, this negative 1, 1.
No, you're right. It goes up on the right side.
Okay, when you're done, I'll show you the computer generated ones and you can see.
Will you draw yours now?
Close. What?
Can you draw yours now?
When you're done. Yeah, I want everybody to have their own mind first. It's reasonable. All right, so everybody got 3 drawn there? Okay, let me just show you. Here's the blue one.
What? Oh. Oh my lord, I was like, what do you mean? Oh, mine's kind of like that.
So negative 12 goes right here. And then it goes down a little bit to negative 1/2, sorry. My brain shut off for a moment there. And then at some point, it kind of levels off, so it needs to go up. And then if you just follow these, it's kind of behind it all. Okay? So everybody got that one? It seemed like they had that one. You all had that one. This is that one. That's the green one. Yeah, they're all turned.
Turn.
Turned. Turned is not a word.
That's a green one. Yeah, that's a. Well,
Yeah, that's the green one. Starts right here.
So if it's a similar shape, but it's not exact, it's okay.
Okay. It's all relative, but yes, I would say.
Like if it doesn't go through the exact same points, but it's the same.
Well, you can't go, you're not really, let me see. Yeah, I would call that okay, yes. Okay? All right, so you're good. So those are your solutions like you found in that the second section. You had verifying, then you had general solutions, you had unit solutions. These are what you're looking for. Okay? In the third section. All right. We haven't done any of these, but this is really what you're going to do more of than even making. Okay, we're going to match 1, 2, 3, 4, 5, 6 differential equations with the 6 right here. Okay? Now, we got to start eliminating. You are not, don't make yourself crazy. First of all, let's look at ones that just have a y. Okay? Now, if the graph just has a y, it just depends on y. Y equals 0, y equals 1, y equals 2, y equals 3. What are you going to be looking at as you go? Y equals 0, 1, 2, 3.
Y, the x-axis.
It's going to be the same, it's not going to change.
The horizontal ones are going to be the same. So let's think about this, because this is what really will help you. All right, so let's let y equals 1. Okay. The x, it doesn't matter. So at y equals 1, that's right here, right? What is the slope going to be? Sine of 1 is, you don't know that, but it's going to be the same, right? Are you all with me?
Oh, yeah, you don't know how to solve that.
Do it?
No, I don't know.
Okay. All right, let's do this one over here. 1 over y. Okay. At y equals 1. 1 over 1. Okay, so for all the y's, slopes are 1. So let's look. Here's y equals 1 right here. Are they all the same? So this is not 3. Okay? Here's 1. Are these all the same? So it's not 2. Now are you with me? Okay. 1 is this. These are all the same? So far, so good. Okay. How about these? Yes? Okay. These? No. And no. Okay. So we know we had 2 that include just y's. We have 2. Okay. So then you have to figure out, well, let me just plug in some numbers. Honestly, if you can find zeros, those are good. Do we have any? What are we left with? 3 and 4, right?
1 and 4.
1 and 4. Okay. All right. So let me get these out of here. 1 and 4. All right. You see any zeros in 1? Any 0 lines? Where? I don't see any. A 0 line is not vertical, it's horizontal. You see any 0 lines over here? Where? Those are 0? They're going every time. The x-axis. It looks blank to me. It looks blank to me. Got it? All right. I was going to eat 4. Five is. I believe so. I hope, I was gonna go check it out. I hope we didn't just miss the first 3 lunches.
I mean, I don't think we would.
I wouldn't think so, but never know.
Is 5 sine of 1?
Maybe. Maybe. Where's my graph here?